who actually figured out how lightning works, and how could anybody find this kind of dangerous thing out? Okay, look at that. It's called the kite experiment, and the answer is Benjamin Franklin, through attaching a pointed conductive wire to the apex of a kite. I need something to draw this. Benjamin looked out of the window and saw a thunderstorm approaching, like big gray clouds. And then he made a real great experiment with his son, William. He said, "William, come on, can I have your kite, please?" And they took William's kite and attached a pointed conductive wire here on the apex. The kite string is wet. That's really important. They flew with this kite and the conductive wire near the thundercloud. So what they found out is that they could conduct here electricity, static electricity from the air, and conduct it down to the ground. Who was it? So Benjamin Franklin was the first person on Earth who figured out how lightning works. Wow, did you see this? When two paths of the lightning connect, this you can see from up and from down. Let's see. Let's understand this together. So a thundercloud is like a giant battery. The top is positive, the bottom is negative. The negative region is the biggest, so I just draw here more. Negative charged. The ground is positive, and then two paths can develop, and like you have it in normal electricity, the circuit will close here. So again, we have this cloud, and the cloud is mostly negative because here we have so many negative electrons. Mostly it's the gravel, it's the bigger part of the stuff that's inside a thunderstorm. The little icy parts are up here, and there's a storm inside. The gravel, the bigger parts, take away one electron from the smaller icy parts, so the smaller get up, they're lighter, and the bigger ones sink down. That's the gravel, they're negatively charged. So there's such a big negative charge up here, it repels the electrons which are on the ground. So the electrons which make something negative move down deeper into the soil, and it leaves the surface positive charged, and this is just how physics work. It's called electrostatic induction. Let's do it, electrostatic induction. It's not a straight line from up, not a straight line from down, but it's like zigzag. Where does a zigzag come from? Let me Google. Why is lightning? Or should I just ask AI? I have a question about lightnings.
Yeah, let's hear it. What's on your mind about lightning?
So I was thinking about the negatively positively charged sides, and I understand that they connect like a circuit. Yes?
Exactly. It's like nature's giant electrical circuit. When those charges build up between the ground and the cloud and then finally connect, that's when you get that big flash of lightning. So yeah, you're totally on the right track.
Okay, understood that. But why are both sides of the lightning, from the clouds and from the ground, why are they not just straight? Why are they like a zigzag line?
That's a great question. The reason lightning isn't straight is because it's finding the path of least resistance through the air. So it kind of zigzags around, following little channels until it reaches the ground. It's just the lightning taking the easiest route.
Okay, AI just told me that the lightning flash from up and from down, It takes the path of the least resistance. What you need is ionized air. This is where the lightning can travel the best. Ionizing means just ripping electrons off the air molecules, and a thunder cloud is just so electric charged that it can do stuff like that. So in the air you have oxygen, nitrogen, whatever, and when you pull one electron off, that's called ionized. So the electric field in a thunder cloud is charged enough so it starts steering electrons off the air molecules like oxygen, nitrogen, whatever. And the air becomes charged. Like the air becomes a conductive channel. And so this electric circuit from the cloud, from the ground, it can close. Well, and then you have light. It's just electricity.